All right, so here's some pictures on coordinate axes. We call them graphs. They are all relations. Right, so we say they're all relations. They display a set of inputs with outputs. They're all joined up, so they're continuous. So they're definitely all relations. But we want to identify the actual functions. And a nice trick is the vertical line test, right? So if you draw a vertical line, we should only cross a function in one location. Now the idea is that mathematicians love functions because they offer some reliable predictions. All right, so if I give you, let's go on to this particular graph. If I have this x input, then it gives me this one output. So anytime I put an x number into the function, out will come just one y value, one output. So in terms of prediction, you only get one output predicted for every one input. However, when you go over to maybe this one over here, if I put this number on the x, then the picture predicts two possible outputs, right? One at the top and one at the bottom. And so it's a nice picture. It's the equation of a circle here, but it is not a function. So functions, we go very quickly. Function, function, not a function, 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 and not a function. Okay, that vertical line test should only cross the picture in only one place. All right, so the vertical line test. So once you've identified function or not function, we go ahead and find the domain and range. Now, it's important to know that we can find the domain and range for all of these pictures, right? All of these pictures, but we're just going to concentrate on the functions. All right, so again, I'll just concentrate on the functions now. And another top tip is that if you make a highest and lowest value for the x, basically those are the x values that we can feed into the function. And then if I choose a different color, maybe in green, and do the same kind of box idea for the y values, lowest and highest. So you create yourself a nice little grid, and then you just translate that into symbols. Okay, so the x values go from here to here. And so I think that is I think that's -6 on the x to +6. We indicate the inputs as x. And then we just need to use the inequality symbols, less than or equal to and greater than or equal to. Now it's important that we get the right symbols. I'll go straight on to the range now. So the range is, clearly you can see the lowest part of the graph is here and the highest part is here. So basically if you walked all the way along this graph, what's the lowest height you'd reach? What's the highest height? So the range in a function topic would be to match the same kind of thing that you've done for the domain. We definitely reach a height of 0, and we also reach a height 1, 2, 3, 4, 5. I think we go up to a height of 6. Okay. The second one's slightly different, right? Because what we can see is for the x values, quite easy to identify from where to where. But you'll notice that this x value here has got a filled-in circle, and this endpoint is a hollow circle, so we don't include the extreme value. So the x numbers here, the domain, will be less than this upper limit, but greater than or equal to the lower limit. Okay, so 1, 2, 3, 4, 5, 6, 7. And the upper limit, 1, 2, 3, 4, 5 is the x. And we don't include the 5, we can have 4.99999. And then you can see that the range is from here to here. Okay, so we've got the y values on the y-axis go from this lower value to this upper value, but we don't include that upper value. So the y values less than a height of 1, but greater than or equal to a height of, I think that's -3. Okay, 2 more. And the ones down here, a little bit unusual. So again, let's go for the domain. So this is the lowest x value. But actually, this arrow means all the x values just keep on going. So it's an easy way of writing that. We just say that the x values are greater than 0. Notice we don't put equal to 0 because it's a hollow circle. So we don't include the actual end point that the line starts at. So it is definitely a greater than 0. Now the range is an interesting one, isn't it? Because if you think about the possible y values, all of these y values are exactly the same y value. They're all 5, right? So we actually have a weird range, y equals 5. Most of the other ranges have had inequality notation. And then finally, we've got to understand that what these arrows mean now. When they're kind of going off at an angle, then it means it keeps going on in the x direction and it keeps going up to infinity in the y direction. All right, so the arrows indicate that it just keeps going on forever. So how do we indicate that mathematically? Well, basically, you can see that all the x numbers, well, the x numbers will keep going on forever in this direction and forever in this direction. So we want all x numbers possible. But the way we write that, we say x is an element or a member of the real number family. So R for real numbers, and R for real numbers means every number possible that we've met: negatives, positives, decimals, fractions. The range is kind of similar, but remember the lowest value is here, and the highest value we just keep going. So the lowest value looks like as if it hits a height of 0. So the y values are greater than or equal to 0. And that's the acceptable notation for domain and range. You might come across other notation which includes square brackets and curved brackets, but we will be using this inequality notation. Hope that helps.